Now that we've seen SOLIDWORKS CAM Standard and SOLIDWORKS CAM Pro, let's take a look at the functionality that's available in CAMWORKS Standard. CAMWORKS Standard includes all of the functionality in SOLIDWORKS CAM Standard and SOLIDWORKS CAM Pro, plus it adds wrapped feature creation, rotary milling using a programmable fourth axis, and two-axis turning with a subspindle. So next, let's take a look at CAMWORKS Standard in action. So here's a motorcycle grip that we might want to machine, maybe make it out of billet aluminum, and I've designed this grip in SOLIDWORKS, of course. And there are actually three configurations for this grip. So this is the default configuration that you see here. That's just a turned part. Then there is another configuration where there's some slots in the grip for the rubber inserts that we might want to put into the grip to make it more easier to hold on to and safer, you might say. And then there's also some vertical slots. So here's a third configuration with vertical slots for rubber inserts. And this part shows nicely the difference between SOLIDWORKS CAM Pro and CAMWORKS Standard. So CAMWORKS Standard supports subspindles. It also supports rotary milling. And this particular version of the grip, or this configuration, requires rotary milling. So this configuration we'll need to use CAMWORKS Standard for. The other two configurations, including this one with the horizontal slots, can be machined using SOLIDWORKS CAM Pro because it does not require simultaneous fourth axis machining. It only requires positioning and then a straight mill across the slot. So you might say indexing or 3+2 machining. Okay. But let's begin with just the turned part, the default version, and we can create all three of these configurations using CAMWORKS. So here, if I go to the CAMWORKS feature tree, you can see I have three CAMWORKS configurations that correspond with the three SOLIDWORKS configurations. So we'll begin with the turning here, and this could be programmed using either SOLIDWORKS CAM Pro or CAMWORKS Standard. And we'll go ahead and go to the CAMWORKS tab and extract the machinable features. You can see the machinable features here for the turning. One thing I might want to do on this second setup is face this other side before I spot drill and drill it and then bore it. So let me go to this particular setup and we'll create a new turn feature, which will be a face feature, and then just pick this face that we want to machine. And now we have that face feature. I'd like to do that before I do the ID feature, so I'm going to drag and drop it into place. And now we can go ahead and generate the operation plan for machining. So you can see the operations have been generated. I'll go ahead and create the toolpaths. And now we can go ahead and simulate the program. So you can see the part being turned here. And it's flipped over, and then the second side is machined in the second setup. And if it's the drill there, and if I go to the compare, you can see here we can compare the design model to the machined model. And you can see everything in green is machined net to the design. So everything was machined nicely here. We'll say OK. And you can see, so very quickly, we're able to generate the turned program for turning this part on our CNC lathe. And now we could go ahead and post-process, give the file a name, and then generate the G-code for the CNC lathe to do the turning on this part. Okay. And here's the G-code. And this actually has both setups in it. So if we had a lathe that did not have a subspindle, we would have two setups, one for the for the first side and then flip the part over and machine the second side. So you can see how quickly we were able to generate the turning program. Now let's go to the horizontal slots, so the next configuration, and notice I changed the CAMWORKS configuration, so it's asking if I want to change the SOLIDWORKS configuration that corresponds. And you can see that here. So here now we have the second configuration with the slots that we'd like to machine. And this will be the milling program now to machine these slots. So let's go ahead and create a new mill part setup. And this will designate what direction we would like to machine from, the Z-axis direction. And what I'd like to do is go to the right or top work plane here. Let's look at that one. And that one is what I'd like there. I want to come straight down on top of one of those slots. This will be the Z-axis direction for machining. So I'll say OK. And then under that setup, I'll go ahead and create the feature for machining. So I'll go ahead and select the bottom of the slot here, and then the end condition will bring up to this point right here. Say OK. And now we have that brown pocket, as it's called, ready to machine or defined under our feature tree. So now what I'd like to do is pattern that around the part. So create a pattern here. I'll create a pattern. It will be a circular pattern. I can just pick the outside of one of the round surfaces on the part and then go ahead and put in the number of slots that I'd like, in this case 6 slots, and say OK. Okay, so I have my brown slots defined. There's also now a set screw hole here for holding the grip onto the motorcycle handlebars. So what I'd like to do here is, in order to define this, I can just use extract machinable features, and it will find that hole for me. So you can see the hole here. Probably like to do that hole first before I do the milling on the slots. You can change the order, whichever order we like here in the CAMWORKS feature tree. And then we'll go ahead and generate the operations for machining. And you can see the operations here, generate the tool paths, and now I can go ahead and simulate the machining of the second configuration of the grip. And you can see there's roughing, finish, machining there, finish milling, and then there's also the chamfer mill that goes around and chamfers these slots as well. And again, I can compare the machined model to the design model, and we can see that everything is in green and everything was machined nicely. So you can see how quickly I'm able to generate programs using CAMWORKS Standard, or SOLIDWORKS CAM Pro could also be used for this particular configuration. Okay, so now I'd like to go to that third configuration, and I'll select it, and again, display that configuration, the SOLIDWORKS configuration, and you can see that configuration here. And now what we'd like to do is to generate the program for this particular set of, or this particular configuration of the part. So again, I'll go here and go to the mill part setup, create a mill part setup. There's the Z-axis machining direction. We can see that by the red arrow here. I'll say OK. And then I'll go ahead and create some wrapped features. So these will be the wrap slots here. If I just pick these, I can just pick each of these and it will select them. And then for the end condition, I want to say the outside of this surface here. And now you can see the 3D slots there in green, highlighted in green, are the features that we'll be machining. That looks great. So I'll say OK. And now the features have been inserted and you can see those features here. Again, I'll go ahead and extract the machinable features. That'll get me my set screw hole. And same thing, let's go ahead and machine that prior to milling of the slots. And now that we have all the features defined, we can go ahead and generate the operation plan, and then go ahead and generate the toolpaths. And then go ahead and simulate the machining of the part. So we'll run simulation here again. And you can see here how these slots require continuous 4-axis or simultaneous 4-axis machining. And so CAMWORKS Standard, this is what CAMWORKS Standard adds to SOLIDWORKS CAM Pro. CAMWORKS Standard does everything SOLIDWORKS CAM Standard and SOLIDWORKS CAM Pro does. And it adds to it the ability to do rotary machining like you see here, the wrapped features, be able to create wrapped features and machine wrapped features using the rotary milling. And again, I can compare the design model to the machined model, and you can see everything is in green. So the machined model exactly matches the design model. And this all looks good. And now also let's look at what happens when a design change occurs. So if I go back to the SOLIDWORKS feature tree, and let's take a look at this wrapped feature here. And here's the sketch for that feature. And let's make a design change. So let's suppose that a design change occurs, and we'll make the slots narrower, let's say 10 millimeters, and we'll make them a little shorter as well. We'll change this dimension to 30 millimeters, then say OK, and we'll go ahead and rebuild the part. And you can see that's a pretty major design change there. And so when I go back to the CAMWORKS operations tree or feature tree, any of the trees from CAMWORKS, you can see it immediately knows that a change is made to the design and asks me if I want to update the toolpaths to the new design change. So I'll go ahead and say OK, and it will rebuild the toolpaths for me. And you can see how quickly it's able to update the toolpaths and program, CNC program, to the new design change. I'll go ahead and simulate now. And you can see now that the slots are being machined and per the new design change where they're narrower and shorter. And so very quickly the toolpaths have been updated thanks to the associativity that CAMWORKS has to the SOLIDWORKS model. And this is the associativity and the updating of the toolpaths. This is true about all 3 configurations. So if a change is made to any of the 3 configurations, then the toolpaths will update automatically. You can see here again, I'm comparing the machined model to the new design model, to the changed design model. And you can see everything is in green and looks terrific. And of course, using CAMWORKS Standard, parts like these can also be programmed in SOLIDWORKS assembly mode. So for example, I could go to an assembly like this that includes all the fixtures that might be required to machine a part like this on the vertical machining center. And these fixtures can be included in the simulation. And you can see here where we can run the simulation, see the fixtures, and also do collision detection against the fixtures as well. So that about wraps it up for CAMWORKS Standard. Thank you for watching. For more information, go to www.camworks.com.